Hello and welcome everyone to my channel, guys. Today for the third episode of ESP programming we have the ESP12 model with us, and we'll see how the hardware side of our project, followed by rigging up the circuit, programming in the Arduino IDE, and the final output. So stay tuned and let's get started. Coming to the hardware side, guys, we'll need some bunch of LEDs, we'll need some bunch of jumper wires, grab some male to female, female to female jumper wires. We will need USB to TTL converter. If you don't have it, don't worry. If you have Arduino, then you can make work out of it, but most of the time Arduino will not give enough current to drive our ESP8266 Wi-Fi module. So better to use a USB to TTL converter. I will prefer to use USB to TTL converter because it will support our ESP Wi-Fi module with enough current so that I can program it. I can make use of its functionalities. So the main part of our project is our ESP8266 Wi-Fi module. This is the model what we have used in our previous video. This is the model 1 and this is the model 12. So you can see the difference in the physical difference. Also you can see here there are only 8 pins, and here we have got 22 pins all around our ESP8266 Wi-Fi module. So we'll be discussing about what and all the features we will get over here. So first let's get started with the band. What it supports, that is the ISM band. It supports 2.4 gigahertz. The power amplification factor is 2.5 dBm, and it supports IEEE 802.11 BGN. So all the features are like ESP26601 module, and we will get more number of pins here so that we can try toggling a lot of pins, lot of LEDs using our ESP26612 model. So here you can see the reset button, and you can see analog to digital converter. We can see chip enable pin here. These are all the GPIO pins, the VCC, the ground. These are all the GPIO pins. TX, RX is also given. Here is the chip selection button, or the pin you can say. Here the MISO, that is the main input slave output, and two GPIO pins, and we have main output slave input mode also, and here is the clock pin over here. So NSK Electronics have provided us with the board here. So this PCB board will be very handy to use because when you will buy it online, you will get only this piece and you have to solder it out everything. So what NSK Electronics have provided is very great, and you can find it online also in this website nskelectronics.in. So they have provided us with 5 volts and ground supply if you are using a mobile charger and all for your power supply, so that you can make use of this, because these two pins are connected with our step down transformer over here, which will convert 5 volts to 3.3 voltage, and we also have a capacitor over here so that our module is not affected with lot of current. And we'll also have external TX RX pin for 5 volt supports, and they have provided us with LEDs so that we can see the power up of our board. And here is also a reset button over here. So our ESP826612 model will be having two modes to work it on. So first is a UART mode for serial communication. For that, GPIO 15, GPIO 0 and GPIO 2 should be high. Please make a note of it. And for flashing it, we will need GPIO 15 to low, and both GPIO 0 and GPIO 2 should be high. So these three pins are more important because these three pins are associated with the mode of working of our ESP266 model 12. So on the software section, we'll discuss about how to program it and how should be the pinout diagram. You can rig off your circuit, and let's get started with the software part. Guys, before going into the software section, so let us discuss about how the pinup should be. So we have our USB to TTL converter, and then we have our ESP8266 12th model. So now how to connect this both, and we might use one breadboard, and we need some few LEDs for that. Yeah, so let's get started. So VCC of our TTL converter should be connected to GPIO 2. Then we can see it is connected to VCC, and then we have to connect it to CHPD, that is the enable pin. And then the ground of our TTL converter is connected to the GPIO 0, GPIO 15 and ground of our ESP8266 model. And then the RX of TTL is connected to TX of our ESP model, and then TX is connected to the RX of our ESP model. So this is how the connection should be for serial communication. And then furthermore, you can connect your GPIO 5, 4, 13, 12, 14, 16 to positive part of your LED, which is the longer wire, and the shortest wire is connected to the ground. You can short it with this ground. You can take the wire from here, you can short it here. All this ground you can short it with this common ground. So this is all about the pinout and how the connection should be made. And now proceeding to our Arduino programming, how the Arduino programming will be done. So the program what we have is almost same like what we did it in our second part of our programming ESP8266, that is episode 2. So it is almost same, but here what I have done is I have initialized all the pins of our ESP8266 model, and then I have created some web pages for extra buttons, on and off buttons, and then I have initialized the pin mode, like what it should be out, like low, or I have initialized all the pins with low in the initial process. And then the changes what I have made is like I have created a server communication method for all the pins, so that any button press, like if you press the on button, then the server should know to make the pin, corresponding pin, high. So for that all the specifications is made over here. So if it is high, if it is on, then pin number 12 will become high. If socket 1 is off, then pin number 12 will become low. So I have repeated this step for each and every pins associated with the socket, and then thus our program ends here. So after your program will end, you have to do the same process what I have shown in ESP programming ESP in the episode 2, that you have to verify it, then you have to upload it, and make sure in your tools you have selected generic ESP module. So don't go for selecting Node MCU or Node MCU 1.0. You can just select generic ESP8266 module and select your uploading speed. Don't make any changes up in here. It's all by default, and it will work fine with this all specifications. And then you can try uploading your code. So after uploading your code, you will get your IP address, and then just copy the IP address and paste it on your browser and start toggling your LEDs, which I'll be showing you right now. Here we have the ESP8266 server. I am switching off all my sockets. Now I will try switching on all my sockets here. Number 3, number 2, number 1. As you can see, the response is very fast. So this is how you can make use of your ESP8266 Wi-Fi module. Thank you for watching the video, guys. Please like, share and subscribe, and whatever you have doubts with ESP or Arduino, please post it on the comment section below. I'll be very happy to helping you out. And special thanks to Prashanti for the awesome logo what she have made. Thank you everyone. Thank you for watching.